possibility. We might not be here tomorrow. Okay? No, not yes. Well, no. Because that means there's going to be a crap ton of snow, and we just got rid of the snow. Yep, we haven't even gotten there yet. Okay? So they're talking 4 to 8 inches tonight. Okay? And then 40-mile-an-hour winds. Okay? So possibilities there. As of right now, we have 1 snow day left. Okay? So if we're off tomorrow, then we're just off tomorrow. Okay? If it comes back and we're gone or we're not here on Monday either, because they're talking 20 inches of snow on Sunday. Okay? Right? Then you'll have to check Canvas to see what we're doing on that day. Or your email, because we might just email you a worksheet to do that day as it, and then have office hours.
So do you have to do your work at the same time as normal, or can you just
At any point in time during the day, but teachers are only like have office hours, if you will, from like 9 to 2, I think is what we're required to have be available. So you can do it outside of that time, but then you just like if you have questions, you won't be able to log onto a Google Meet and ask. Okay? So with that being said, again, the only thing that I know now, right now, at 1:03 on Thursday afternoon, only thing I know is you have a quiz scheduled for tomorrow. Okay? Other than that, everything's kind of hodgepodge. Make sure you're checking your email. Okay? And your Canvas and all that stuff. Especially if we're gone for multiple days. Okay? Okay? So, with that being said, on page 6 in your note packet, we're in your note packet right now. On page 6, there are 4 angle relation problems for you to tackle at this point in time. So I would like you to try those right now. Go for it. In letter A, what do I know about those 2 angles? What do you mean they equal 180? So x is 180 degrees? Because that's what you're just saying. It's saying that they equal 180 degrees. You're missing a very key word. No? So I add them together and it equals 180. Okay? It's a big difference. When you just say they're equals 180, it means that they're 180 degrees. Okay? But together, add them together, they're 180 degrees. Okay? So x plus 152 is 180. So how am I going to solve that? Minus 152, 28. Okay, I knew it had to end in an 8. So x is 28 degrees. Or the measure of angle MNP is 28 degrees. Either way. Okay. What do I know on letter B? What do I know about those angles? They all are 180 degrees?
So they're all 60.
They have to add up to be 180 degrees. Yeah. Can I ask you first a quick question? Are you in a foreign language? Which one? Spanish. When you go to Spanish class and you start talking French, does your teacher look at you funny?
Yeah.
Okay. Math is a foreign language. Okay? It really is. Because we have our own terms, we have our own, you know what I mean? We say things a certain way, etc., just like you do in Spanish, right? So when you don't say things right, it's my job to correct you. So don't get all huffy at me because I'm correcting you because you didn't say add to be 180 degrees. Okay? 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 Alright, so they add, all 3 of them had to be 180 degrees, what you're saying? Plus, they're not all 60 degrees because this one's only 37 degrees and that one's only 45 degrees. Okay, so if it was an equilateral triangle, then they would all be 60. Okay? So x plus 37 plus 45 has to be 180. Well, what's 37 plus 45? 82. Okay. Then I'm going to solve that by subtracting 82. 98. Not just a boy band from the early 2000s. Okay. DBC. All right, what do I know about those two angles? They both add up to be 90 degrees. And how do I know that they add up to be 90 degrees? Because of that square right there, right? Yep. Because that square tells me that that's a right angle, which means that that big angle there is a 90-degree angle. Yep. Okay. All right. So 2x minus 4 plus x plus 7 has to be 90. Well, what's 2x plus x? 3x. Negative 4 plus 7. Positive 3. Am I going to solve that? Subtract 3. Then divide by 3. 29. So it's 29 degrees? So we want the measure of angle DBC. So we want this one, right? So I have to put 7. So I got to put this back into that one. So x plus 7 degrees would be 29 plus 7 degrees. So the answer here of angle the measure of angle DBC is going to be 36 degrees. Okay. It says find the measure of angle LPQ, that's x plus 28 degrees, and LPN. Okay. All right, we can handle that. Okay, what do I know about those two angles that are given? Because they're supplementary? Yep. So that's 2x plus 28. Subtract 28. So 2x is 152. Divide both sides by 2. X is how much? 76. Okay. LPQ is this angle right here. So that would be x plus 28 degrees. So then that's going to be 76 plus 28 degree, or plus 28. I put squared, it should have been degrees. Sorry. Almost did it again. 28 plus 76. 104. So the measure of angle LPQ is 104 degrees. Okay. Then it said we also need to find the measure of angle LPN. That's that purple one. What do I know about the measure of angle LPN and X? They're vertical angles, so those are equal to each other? Yep, okay. So the measure of angle LPN then would be 76. Questions on any of those? Good. All right. So, we've got two triangles that are shown, and they could be congruent. Okay? If they are congruent, what do I know about them? So, my question, let me rephrase my question. If two triangles are congruent, what do we know about them? So their corresponding sides and their corresponding angles are all equal? Okay, all right. So one way to show that two triangles are congruent is to show that all of their sides are equal, or their corresponding sides are equal, and their corresponding angles are equal. Yes? Okay, all right. So if I'm looking at triangle ABC right here, I don't know side AC. Correct? Okay. How can I find side AC? We can use Pythagorean theorem, right? Okay. So 6 squared plus 8 squared would be side AC squared. 6 squared? 36. 8 squared? 36 plus 64? How am I going to solve for the length of side AC? Square root. Okay, what's the square root of 100? 10. So this side length here we just showed was 10. Okay. On triangle DEC, I don't know this side length EC. How much is that going to be? 8, right? Because we've got 6 and we've got 10, we've got 6 and we've got 10. So this one's got to be 8 because it's a right triangle. Right? Okay. So do I have all of the sides or the corresponding sides equal? Yeah. So we've shown that. Okay. All right. What do you know about right angles? They're 90 degrees. So both of these are 90 degrees, right? Are they equal? Yeah, because they're both 90 degrees. Says so with that little square in the corner. Okay. What do I know about angle ACB and angle ECB? Excuse me, ECD. They're vertical, so what does that mean? That means that they're equal, right? Okay. All right. What do I know about angle A and angle D? Mm-hmm.
So whatever the vertical angles are, that.
So whatever they are, let's call it, can we call them just X for right now?
Yeah.
Okay. So if that one is x, then this one is x, right? Okay? And so what I hear you saying is, I hear you saying that in triangle ABC, then that the measure of angle A plus the x plus 90 has to equal 180. Is that what you're saying? Yeah. Okay. So if I subtract off 90, then the measure of angle A plus x would be 90. Is that what you're still saying? So then the measure of angle, oops, I forgot the angle part of, I just put MA. So then the measure of angle A is going to be 90 minus x in triangle ABC.
Oh, yeah.
Yep. Okay. Okay, that's what I thought you said. Then if I go to triangle DEC, then I'm going to say that the measure of angle D plus x plus 90 equals 180. Same thing, right? Subtract off 90, subtract off x. So then we would get here, the measure of angle D would be 90 minus x. And then let's put that in degrees. So what can you tell me about angle A and angle D? They're the same, right? Okay. So we've shown now that all of our sides are correspondingly equal, and all of our angles are correspondingly equal. So what can you tell me about those two triangles? They're not equilateral because they don't have all the same side lengths. They're what? They're congruent. Okay. Equilateral means that the triangles have all the sides of the triangles are the same. No, because this side is 6, that side is 8, and that side is 10.
I'm thinking like both.
Corresponding.
Yeah.
Yes. Yes, that's not equilateral. Yeah, equilateral is one triangle, all the sides are the same. Okay. Okay. What we're going to get into today is different ways to prove that triangles are congruent. Okay? You may wonder, knowing if that two angles of the included side of one triangle are congruent. Okay? So, it's all about how, or I shouldn't say how, it's all about what you are given. Okay? So it helps to draw yourself out a picture. It helps to put on that picture geometric markings. Slashes through sides, arcs through angles. Okay? That helps because that's going to help you in many, many ways. Okay? So the first way that we can prove that two triangles are congruent is by something called angle side angle. And how angle side angle works is you've got an angle, then you've got it's a side in that order, followed by another angle. Okay, it's got to be in that order. So it's two angles and the side that's in between them. Okay, that's what makes angle side angle. It's two angles and the side that's in between them. Okay? If you have those congruent on two different triangles, or you have those parts equal, you've shown that, then you can say the triangles are congruent using what's called ASA, angle side angle. Okay? Now, what I was saying was you've got to show that on two triangles, which we just did because of our geometric marks, but then that helps us to name those triangles. Okay? Because remember, naming order matters in terms of your lettering. Okay? So on one triangle, you get to just say whatever the triangle is. So let's go with the left triangle. What would you name the left triangle? what would you give for a name for the left triangle? CAB. Okay. Is congruent to, okay? So now you've got to match up letters in the other triangle. Okay? So angle C currently is the angle with nothing in it. It's got no geometric marks in it on the left one. Alex, what is the angle on the right triangle that has no marks in it? Well, you got to use your eyes, okay? And it's very hard for you to use your eyes if your eyelids are closed over the top of them. So you got to wake up, okay? All right? So let's look at this picture, Alex, right here. You got it in front of you too, hopefully. Which is, so C is the only one without any geometric marks in it, right? Which one is the one without any geometric marks in it over here? T, okay? So then we would start with triangle T, because C has to match up with T. Okay? Then we went to the blue angle, right? So what's the blue angle on the other side? R. And then we went to the third angle. What's the third angle? S. Okay? So that was, if we name the first one CAB, the other one has to be named TRS. Okay? Let's tweak it up a little bit. Let's change the first one. So give me a name for that first one that's not CAB. ABC. Okay, I love it. So triangle ABC. You now name the right triangle based off of triangle ABC. Let's do it. Started with the blue angle. So what's my first letter? R. Went to the red angle. Went to the no angle. T. Okay? Two different congruent statements, both from the same figure. Okay? All right? And order matters with that name. Okay? We're not going to use tracing paper. We get it. They're congruent. I'm telling you that there is. Sometimes you just got to believe me. But if we were to trace it, you would have to rotate it around, maybe flip your tracing paper over and show it that they are congruent. Okay? There are some other conditions that also work for proving triangles are congruent. Okay? The next one is side, angle, side. Side, angle, side, you would have a side that's congruent on each triangle. Then you would have another side that's congruent on each triangle. And you would have the angle that's in between them, in between those two sides that you have. That's called side, angle, side. Okay? That is a way to prove triangles are congruent. Okay? Triple A, angle, 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 does not prove triangles are congruent. You have to have at least one side to set the size of your triangle. Okay? And the reason is, let me see if I can do this now. Here, there's the triangle, there's the triangle, oh, there's the triangle. So here is a triangle, right? And I can do, let me see if I can do another one on top of it. There we go, yep. Okay, so I can put this one right over the top of it, and those two would be congruent, yes? But if I expand this triangle out here even more, now, come back to me. Those angles are still the same. Okay? This top angle is still the same. This angle here is still the same. And this angle here is still the same. But are those triangles congruent? No, because they're totally different sizes. Okay? Right? So angle, angle, angle is not a way to prove that triangles are congruent. Okay? Side, side, angle. Okay? Or angle, side, side, if you will. Okay? Yes, it spells ass. Okay? Hee hee ha ha. Okay? It's not a way to prove that triangles are congruent. Okay? And that, by the way, is one of the easy ways to remember it. You can't prove triangles are congruent with your angle side side. Okay? Alright? Side 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 is a way to prove triangles are congruent. Okay? If you have all three corresponding sides, then it's congruent. Oh, we haven't gotten. So there's one more out there. Did we get to it on the next one? Nope. So there's one more out there, and that's called angle side angle. Okay? So so you got 5 different ways to prove that triangles are congruent. Okay? So here are those 5. Okay? So you've got side, 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 where you have 5 congruent, or where you got 5, where you've got 3 corresponding angle or side pairs. You've got angle, angle, side. You've got angle, side, angle. And you've got side angle, side. Okay? Hypotenuse leg works only in right triangles. Okay? Because you have to have a hypotenuse, and you only have a hypotenuse in a right triangle. Okay? So hypotenuse leg only works in right triangles. Okay? You want to put a little, remember, maybe even crease the corner of your page up there, because you're going to come back to this chart a lot. Okay? All right? This is going to be your go-to. These are the 5 ways that you can prove 2 triangles are congruent. If it's not on this list, it can't be proved. You can't prove triangles are congruent. Okay? So make a little mark there. Highlight it if you will. Whatever you need to do to memorize that, you got to get that memorized. Okay? All right? So let's put it to work. So here are 1, 2, 3, 4, 5, 6 different triangle pairs. I'm going to do 2 of them, and then I'm going to have you do 4 of them. Okay? What we're asking for is if they're congruent or not, so a yes or a no, and if they are congruent, how are they congruent? If it's a no, it's just a no. Okay? So we'll start with letter A. Okay? Letter A has a side that's an 8 on both triangles. It has another side that's 11 on both triangles. And it has the angle that's in between them at 70 degrees on both triangles. Are those triangles congruent? Yes? What's your reasoning? Give me 3 letters. It's a 3-letter answer. SAS. Yep, because we have a side, an angle, and a side in that order. So this would be yes, side, angle, side. Okay. Pick one. B, C, F, G, or H. F? Okay. What about F? We got a side. Yes, because we got a geometric marking for these ones. Yes. We've got another side because we've got these geometric markings. Yes. Do I have anything else? What? Not anything marked? We got him. Oh, do you know that's a 90-degree angle? Does it have the mark in the corner? Then you don't know it. You know what I mean? Okay? Because 89 degrees looks a heck of a lot like 90 degrees, but 89 is not a right triangle. You know what I mean? Okay? So we can't just go off of looks. That's the kicker in this unit. You can't just go off of what it looks like. Well, it has to be because it looks that way. No. You have to prove everything. They are, actually. So what can I say about that side?
Oh, it's the same.
It's the same because it's equal to itself, right?
Yeah.
Yeah. So this side right here is equal to itself. What that's called is, we call that the reflexive property. Or you might also hear it referred to as, oops, not a saved side. You might also hear it referred to as a shared side. Okay? If you think about it, when you look in the mirror, you're the same size. Okay? That's where it comes from. When you look in the mirror, it's the same size. This is just looking in a mirror. It's been reflected over that side. Okay? All right? So are those triangles congruent? Yes. What's the property? What's my three letters? SSS. Yep. Okay? You do the other four. Go for it. Letter B, what do we got? SSS. Okay, because we got a 31. So those sides are congruent. We've got 40. And we've got 42. So yep, that would be side, side, side. Okay. C. Nothing, right? Because what we've got is we've got a side. We've got an angle, or excuse me, we've got another side. But then the angle's in different spots, right? Okay. On the left triangle, the angle is in between the two sides. On the right one, it's not. So that one's a no, because the angle's in the wrong spot. Okay. G. Do we have a side? No. So can we prove that they're congruent without a side? Nope. So that's a no. Gotta have at least one side. We have all three angles, but we don't have a side. Okay? What about H? SAS? Okay? So we have a side. Right? We have a reflexive side. right? But do I have the angle in between those two? No, because that would be SAS. The angle's got to be in between. So this is actually a no, because this is angle side side. Okay? And you can't prove it with your angle side side. Okay? Again, I tell my pre-calc kids, because when you get to pre-calc, we do something that only happens in an angle side side case. And so that's how we remember it. Okay? We flat out just say the word. Okay?
You said angle side side, so I wrote it down.
As angle side side?
Yeah, on accident.
That's what it spells.
Yeah.
Yeah, I get it. It's right. I mean, it's there, but that's how I do it. Okay. All right. So your homework tonight is some more of this stuff. Again, when you're doing your homework, I strongly recommend that you have this out. You can have your notes out when you're doing your homework. I know it's crazy talk, but you have this chart right next to you when you're doing your homework, because there's going to be problems like those 6 that we just did on your homework. Okay. What I'm going to do now is I'm going to hand a bunch of stuff back. Then when I'm done handing stuff back, I will open myself up for stamping. Okay? Okay?